Okay, we're going to take a look at this coordinate proof here, which kind of comes in a couple of steps here. First of all, we're going to graph the polygon JET, the jet, all right? So a couple of things to make sure that we think about. Make sure that when we label, we're adding our coordinates, all right? We're adding our coordinates. So we've got letters and coordinates because particularly on the regions, if it says state the coordinates, we want to make sure that we don't just put a letter. We want to make sure that we also state the coordinates, okay, if we're going to be scoring some points here. So we've graphed this polygon, and the next step is prove that the polygon JET is an isosceles triangle. So isosceles means two sides are congruent. So is it going to be this one and then that one, or this one, that one, or this one and that one? It's hard to really tell here. But if you do kind of look at it, it seems like those two are going to be the ones that are congruent, okay? So how do we do that? There's little notes on the back here. Here is your distance formula, if you want to use your distance formula. Or just create a right triangle and then say the square root of the x distance plus the square root of the y distance squared, okay? It seems like a very simple sort of way to think about it. So I'm going to find the distance from J to E here. So if I'm going to count, I'm going to create this right triangle now, right? I'm just going to go up and I'm going to go here. Okay, so the x distance and then the y distance squared. Okay, so I've got the x distance is a distance of 1 squared plus, and then the y distance is a distance of 1, 2, 3, 4, 5, 6, 7 squared. Okay, so what that is going to be is the square root of 1 plus 49, which is the square root of 50. Okay, now you could leave it like that. If you wanted to simplify that, we can break that down into radical 2 and then radical 25, which is really the square root of 5 radical 2. If you wanted to simplify, usually with these coordinates proofs, radical 50 shows the distance, okay? So let's take a look at the next one. If I go from E to T here, right? So we're looking at creating our right triangle. It looks like it meets right there. There we go. Okay. So this right triangle, the x distance squared here, I'm going to count 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5. Okay, so that's the easier one, right? So I've got 5 squared is the x distance, 5 squared is the y distance, and we've got 25 plus 25, which is also radical 50. Okay, so once we've stated that, all right, we can say that JE is congruent to ET, right? Therefore, triangle JET is isosceles, isosceles. Okay, you want to put your little mark to be fancy right there, or write QED, you can also do that. Okay, the next part is, now what happens if we add something to this, all right, or we try to adjust this? And in this case, it says, look, reflect polygon JET over the line y equals 1/3 x plus 1. So let's start with that first. I'm going to graph the line y equals 1/3 x plus 1. So I've got a point right there. I rise 1, run 1, 2, 3, fall 1, 1, 2, 3. You can see very clearly that we're kind of traveling right along this line right here. Okay, so this represents the line y equals 1/3 x plus 1. So if I'm going to reflect across that line, remember when you reflect something across the line, right, the points are equidistant from each other. So it's kind of hard if we're looking at something like this to figure, well, what's this distance and then what's this distance? But what do you know here? You know that the right triangles are going to be exactly the same. We're going to have congruent right triangles. So the best thing to do is, how do I get from E? Well, I'm going to go right 2, down 1, 2, 3, 4, 5, 6. Okay, so what do I do again? Let's go right 1, let's go right 1, 2. And then down 6. You can see I got a distance of 2 here, down 1, 2, 3, 4, 5, 6. So I'll do it again. Right 1, 2, down 1, 2, 3, 4, 5, 6. And now what I'm going to do is I'm going to state that point S, okay, which is the image of E after the reflection. And that point S is the point 2, comma, -5. So I'm stating that point, and now I'm going to reflect my triangle right over top of that line right there, and then there we go. So now what we want to see here is the polygon JETS a rhombus? Is that a rhombus? Okay, what is a rhombus? A rhombus is a quadrilateral with 4 congruent sides. So what do we already know here? We already know the distance from J to E and E to T are radical 50, okay? Radical 50. So let's check these next two here. So I'm going to check T to S. How do I get from T to S? Well, I'm going 1, 2, 3, 4, 5, 6, 7, left 1. Okay, so the X distance is going to be 1 squared, and then the Y distance is down 7 squared. Okay, so I've got radical 1 plus 49 is radical 50 again. So we're looking like we're in good shape. And as you can see here, if I'm creating my right triangle right here, where do those meet up? They meet up right there. And what are the X distances and what are the Y distances? You can see 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5. There we go. Okay, so I've got my 5 squared plus 5 squared. And we've got the square root of 25 plus 25 is radical 50. Okay, so now what do we know? Well, I've just shown that JE is congruent to ET, which is congruent to TS, which is congruent to SJ, right? And what that means is quadrilateral JETS is a rhombus. Okay, throw in your little therefores. Close out your proof with a little box or a QED, and you are gone, okay? There you go.